Hey everybody, this is me, it's Larry. Why did I say that differently today? Hey everybody, it's Larry. This is day 20 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. So today's farm is 735 Asteroid Collusion. So you're given an array of asteroids of integer represented asteroids in a row. Okay, for each asteroid, the absolute value represents its size and the sign represents its direction. Positive meaning facing right. Wait, facing right or going right? I don't know, but each asteroid moves at the same speed. Find out the state of an asteroid after all collision. If two asteroid meets, the smaller one will explode. If both are the same size, both will explode. Two asteroids moving in the same direction will never meet. Okay. I feel like this is something that we did like on a contest, maybe like 2 weeks ago, 3 weeks ago, or something like this, right? I forget what the context was though. It's been a while. Was it like with cow? I mean, it's not the ants one, but it's like with cows or something. I don't remember. Uh, I don't know. But in any case, yeah. So let's take a look at the constraints, and constraints 10 to the fourth number of things. This one doesn't really matter that much usually, because the speed is constant, we can always normalize it, right? Which means that we can always reindex. Though, of course, in this case, you have to be careful because the negative things means, yeah. Wait. How does... So the positive is facing right. Oh, so the order is the relative position, right? Is that the... And this is the size, and then it's the relative position. So then, okay. Yeah. So that means that the 5 and the 10 is facing right, and then the -5 is facing left. Yeah, okay. So I think this one is just a stack, right? Basically, anytime you have, because you can only yeah, the only I mean, you can implement it in any number of ways, but because this is just like defense based thing. But the thing that comes to my mind first is a stack, unless I'm misunderstanding this problem, because maybe it's a little bit awkward. Because you're always looking at adjacent elements, and then you kind of repeat that, right? So okay, it's just a stack with a rule set. So what did I drop? Anyway, so yeah, let's have a stack, and then now we have 4x in asteroids, right? And we want to just, yeah, maybe just append x, right? And then if length of stack is greater than equal to 2, and then the only way that, and this is a while maybe. It's a little bit awkward maybe, but yeah, so basically there are only two situations, right? So maybe we could write this in a less generic way, but there's really only two situations, right? One is the current asteroid is facing right, so that means that it's looking at a future thing. So then that means we're done. So if x is greater than 10, then or 0, sorry, I don't know, I said 10. We continue. Otherwise, that means that we're facing left, and then we have to look at the stack. So then now, I'm trying to think whether there's a case where, okay, so now we know that this current asteroid is facing left, and so that means that there are only two scenarios, right? That means that so you're only looking at the last two asteroids, one that we're looking at currently, and one which is the one that was previously. So there are only two situations now, because we know that the one that we're looking at now is facing left. Then the one the previous is facing right. If it's facing right, then we do the collusion thing. But if it's facing left, there's what I'm trying to think and making sure. I mean, I kind of thought about it quickly, but it was just thinking that, okay, is there a way that it can see another rock? And there's no, if the previous thing is facing left, it means that there's no asteroids facing right, because it means that this previous asteroid destroyed all the other ones, or there's no previous ones, right? So okay, so yeah, so maybe current okay. If length of stack is less than 2, then we also continue. But this should be a while, so let me think about this for a second, right? So maybe something like right, then current is equal to stack of -1, and then the previous is equal to stack of -2, and as we said, this is going to be the one facing left. Yeah, right. So if previous is equal to, or if the previous is facing left, that means that we're both facing left. Whoops. So then that means that we're done. Otherwise we do a collusion thing. So then now, if can they be 0? Okay, it cannot be 0. Okay, so if this is equal to previous, then we stack pop, and I think we're done. But I guess we'll continue. I don't think we need to do a continue, but but I'm too lazy to think about it. Otherwise, if the current one is bigger, the way I wrote this is kind of awkward, to be honest. So maybe we don't. Maybe I do it this way instead. While stack is greater than 1, current is equal to absolute of x. We know that this is facing left, so this is fine. And then previous is equal to -1. If this is also facing left, we break. Otherwise, if current is equal to previous, then we pop, and then we break in this case now, because otherwise we just keep going. Otherwise, in this case, if then we start pop, but then we continue. Otherwise, else, there's only one more condition, which is this case, and of course we don't even need the absolute value because we already did it, right? We can also like save this, I suppose, but it's fine. And maybe we can do here. Right, now that we know it's facing our direction. Otherwise, the previous rock wins. That means that we break, right? Because that means that we don't add the current thing on the stack. I think this one is a little bit off. Is it? I mean, it's not off, but we have to add the current thing to the stack, and we have to be a little bit careful about when that is. Well, in this case, no matter what, we don't. In this case, we do until we see here. Wow, the case that I put is kind of confusing, actually. Like, there's so many possible states. Like, I know how to fix it, but I feel like that's not really readable in a good way. Right? How do I... let me try to think about how to rewrite this in a cleaner way. Because in this case, we never do it anyway, so that's correct. In this case, the continue is a little bit weird, because even though we pop this and we continue, I guess we can just do something like what is previous? So we can do something like destroyed is equal to false. In this case, destroyed is equal to true, right? And here destroyed is equal to true. destroyed is equal to true. Here, not yet, but you may, because you may do this a few times and then end up here, so then you don't get destroyed. So yeah, if not destroyed, then we do stack.append of x. Yeah, and you have to remember that this is x, not current. And yeah, I think anyway. And then we just return stack at the end, really. I think. Did I spell else wrong? Oh, false. It was a case 3. Oh, there's a case 3. I want a case where the answer has negative on it. Okay, that's good. Same thing, but maybe one where, you know, it runs it over. Okay, let me give it a submit. All right, that actually was pretty good. How did I do last time? What the? Wow, I think last time I did it way more complicated. The power of stack, I suppose, even though this is kind of a tough logic to follow through unless you're very careful. I mean, the logic isn't that hard. It's just that you have to be careful to implement it precisely. But I think after adding the destroy flag, it makes it reasonably easy to understand, if not come up with. Yeah. So what's the complexity here, right? So the complexity here is going to be, linear time, linear space due to the stack, linear time. You have to look at every node. I mean, sorry, or every asteroid. So, yeah, that's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye-bye.